This video is for section 9.2. Our objectives in this section are to form composite functions, verify inverse functions, and find the inverse of a function. So we're going to start with compositions of functions. A composition of a function is basically a way of combining two functions together. And you do that by plugging one function into the other. So if we're looking at the composition of the function f with the function g, there's two ways that we can write that. One is with what's called circle notation. So we can say f and then use a little open circle, kind of similar to like a multiplication symbol, but open circle and not a solid circle. So if we have f of g of x, or another way that we can write it is with nested parentheses. So we can say f parentheses g parentheses x, and we'll see both of these in our textbook. So you'll see them both written both ways in the homework. And what we do here is we plug the inside function in for x into the outside function. So in this case, the inside function would be g because it's inside of f. When it's written with the circle notation, the inside function is always the one in the right. So for both of these, I would be plugging g into f. So I replace the x in f with the whole function for g. So we're going to look at some examples here that should make it a little bit more clear what we're doing. We're going to start with example 1. So we have f of x equals 3x minus 4, g of x equals x squared plus 6. And first we want to find f circled g. So for this one, I'm going to be plugging g in to f. And so what that means is that g is x squared plus 6. I replace the x in f with x squared plus 6. So what that's going to give me is I'm going to start writing function f. So I have 3, but then I replace x. Instead of x, I write x squared plus 6. So x squared plus 6 replaces x, and then I'm going to have 3 times that minus 4. From here, it's just a matter of doing some distributive property stuff and simplifying that we've seen before. You want to get everything combined like terms and all that. So I'm going to distribute here first. That's going to give me 3x squared. 3 times 6 is 18, and then minus 4. And lastly, combine those two numbers. 18 minus 4 is 14, so I get 3x squared minus 14. So f circle g of x equals 3x squared plus 14. Now for part B, what I'm going to do is I'm going to do it the other way around. Instead of plugging g into f, now I'm going to plug f into g. And what you're going to see here is that they're not the same. The order in which you're plugging them in makes a difference. So for this one, I'm going to start with my function g, x squared plus 6, and I'm going to replace the x in that function with 3x minus 4. So I'm plugging f in to g. So what that's going to give me is it's x squared So that's going to be 3x minus 4 squared. I'm going to put it in parentheses because I'm squaring the whole thing. And then it's x squared plus 6, so it's going to be that squared plus 6. So for this one, the simplifying stuff is a little bit more work because now I need to multiply this out. And remember, good review from chapter 5, if I'm squaring something, that means it's multiplied by itself. So I need to write it out twice and then use FOIL. 9x squared minus 12x minus 12x plus 16, and then don't forget that plus 6 there on the end. So now I'm just going to combine like terms, and that's going to be 9x squared minus 24x. 16 plus 6 is 22. So that would be the answer for part B. Now for part C, this isn't in the book, but it is in the homework problem, so I wanted to talk about it really quick. It says f of g of 2, so instead of x here, I have 2 in the parentheses. So what I'm going to do is I already have f of g of x. I found that in part A. So I'm just going to plug 2 in for x into my answer for part A. So that's 3x squared plus 14. So I'm going to do 3 times 2 squared plus 14, and then do order of operations or type this into my calculator. Exponents first, 2 squared is 4, 3 times 4 is 12, and 12 plus 14 is 26. So again, you'll see this on the homework. All you're going to do is plug 2 in to the function that you found earlier. So that's the answer for that. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer with the notes that are posted, and then move on to the homework.